Hi, I'm Jim Stern, and I'm here to give you an introduction to artificial intelligence for marketing. I've been in online marketing since 1994. I've written a slew of books about online marketing, advertising, customer service, etc. And my latest one is Artificial Intelligence for Marketing. Now, I'm not here to teach you how to be a data scientist. I'm here to teach you how to be a better marketing professional. Artificial intelligence is a new tool for us to use, and I'm here to explain what it is, how useful it will be, and how you can up your game so that you will continue to be a valued marketing professional. Here's the outline. First of all, what is artificial intelligence? How does it work? What is it good at? And then what is it good for? First of all, let's talk about what it is not. It is not science fiction. It's not what you see on TV. It's not robots that become self-aware. That is so far in the future. It may not be impossible, but it's so far in the future, it's not worth our time worrying about it from a professional perspective as marketers. Artificial intelligence covers a wide variety of subject matter. So, natural language processing, being able to hear the voice, turn voice into text, text into meaning, and then respond to that using voice or text, natural language processing. Computer vision, the ability to look at a picture or a video and understand what's going on inside it. Is that a cat or is it a skunk? It's also robots and self-driving cars, which as a marketer we're not so interested in immediately, but eventually, yes, we will use robots in the marketplace, in the stores. Self-driving cars will become a platform for advertising. If somebody doesn't have to drive, you can advertise to them. But the most important thing that artificial intelligence provides for us marketers is machine learning. So, what is machine learning and why is it such a big deal now? We've been looking at getting computers to think for more than 50 years. The philosophy of thinking machines, the concept of getting machines to understand for themselves, has been around for a long time. But only now do we have the processing power, only now do we have enough data that we can test out these theories and find out which ones work best. The other thing that's happening is that the whole artificial intelligence community was brought up on the concept of open source. This idea that we're going to put our ideas out there and share them and other people can improve upon them. Machine learning algorithms are being invented daily and are up on the internet for people to play with, whether it's from IBM or Microsoft or Amazon or Apple, Google. They're making these available for anybody to use. So how is machine learning different from the computing that we've been doing for these many years? If you've done any coding at all, you know that a program is specific instructions to the machine on exactly what to do. We know exactly what we want. We tell the computer exactly what it should do. If this happens, do this. If that happens, do this other thing. If you don't know what to do, spit out an error message. A mathematical model is, well, it's an Excel spreadsheet. This is my marketing budget. This is how much I'm going to put into each bucket. This is how much response I expect to get. Now, what if I put 10% more here or 5% less there? What if my return on my investment is 2% higher here and 5% lower there? I can play what if all day long. It's a mathematical model. A statistical model is a bit more sophisticated. I look at all of the data and plot out all the data points and draw a line through them and then project where that line is going to go. And I make a prediction on what the past has told me. I'm dealing in likelihoods and probabilities rather than exact numbers. Both of these methods require a human to iterate over and over, so it doesn't scale very well. Machine learning, on the other hand, derives structure from the data. It infers rules from the data in order to create a model, and then when it gets new information, it can change its mind. This is a really central point. Instead of giving the machine exact instructions on what to do, we tell it how to interpret, and we give it the authority, the ability to change its mind when new information comes in. Now, there are three different kinds of machine learning. And when you're talking to data scientists, this is important to understand the differences. Supervised, unsupervised, and reinforcement. Supervised machine learning is really valuable when you know the answer already. Yes, this is a dog. No, that is not a cat. Yes, this is a friend of mine. The machine needs a lot of labeled data. That means you give it a lot of information where you say, these are true, these are not true. Now you have a bazillion examples. So here's an example of getting a machine to recognize cats. We're going to give it labeled data. That means here's a photograph and we're going to label all of the cats as cats. And it's going to look for what is similar. How are these things alike? Well, they all have these pointy things on the top of their head. They all have these almond-shaped eyes. They're all sort of looking in this direction. And then it looks at this thing and goes, I don't know what that is. That's confusing to me. So you have to give it lots and lots and lots of cats in order for the machine to understand. And when I say a lot of data, let me just show you an example. This is how many data points it's necessary for CAPTCHA to understand that it's looking at the letter A. So that is supervised. You know the answers already. Unsupervised is when you don't know the answer and you want the machine to figure out something for you. You want the machine to tell you something about the data that you didn't know before. So let's look at a bunch of my different customers and tell me what buckets they belong in. These are the ones who are most likely to purchase. These are the ones with the highest lifetime value. These are the ones who are most likely to never buy from me again. Or let's go out and, now that you know what my best customers look like, go out and find others out in the world who look like that I should advertise to. This is unlabeled data, really, really good for categorization. The third category, the third type of machine learning is reinforcement. This is when you're not sure what the answer is. We want to put the right message in front of the right person at the right time. But there is no exact message to put in front of a person at exactly the right time. So we give the machine the authority, the capability of trying things out, of experimenting. And if it gets the right reaction, somebody clicked or they engaged or they purchased, then the machine gets a reward, a mathematical reward. And so it tries to do that better and it tries to optimize over time. So we've got supervised, unsupervised, and reinforcement learning. Okay, that's what it is. But how does it work? So the amazing thing about this stuff is that it actually delivered on the promise of big data. Big data was a great idea, but it's just too much for the human mind to hold. Too many permutations, too many possibilities, too many numbers to keep track of. Fortunately, computers are very good at keeping track of numbers, so that's great. So data scientists created a bunch of algorithms. Now, it's not terribly important that you understand what all of these are. If somebody talks about decision trees or support vector machines, that's fine. Just go along with the conversation. They'll get around to it being meaningful soon. But just for the sake of interest, let's dive into what a neural network is and what deep learning means. This is the simplest of possible neurons. We've got 3 inputs and a decision. The 3 inputs are, how much will it cost to go to the movies? How's the weather outside? And how much work will it be? So how much does it cost to go to the movies? Well, if I want to go to a Hollywood premiere, I have to get on an airplane and rent a hotel room and rent a tux, and that's expensive. That's too expensive. I'm not going to go. Doesn't matter about anything else. I'm just not going. But if it's a normal price ticket, well, the next consideration is, oh, there's a blizzard outside, or it's 120 degrees outside. I'm not going anywhere. So it doesn't matter if it's free. I'm not going to go. Or finally, the amount of effort. Have to get a babysitter, have to stop by and check up on my dad and make sure he's okay. Got to make sure we stop at the grocery store on the way back. Oh, that's just too many things going on at once. That's any one of these can override the others and be the go, no-go decision. Now, neural networks have hidden layers. So in this human example, a hidden layer is the last time we went to the movies, we saw science fiction action adventure. So this time we're going to have to see a romantic comedy. Last time we went, I broke a tooth on an unpopped kernel of popcorn. Bad experience. The last time we went to the movies, my wife and I got in an argument about where we should park. And so that was not a pleasant experience. Now, I'm not consciously thinking all of these things. They're going on back here. So when she asks, hey, honey, do you want to go to the movies? I'm going, not really. And if she says, why? Then I've got to start sorting through all of my thought processes. That's what the machine is doing. It's hidden layers of cogitation. And it can have thousands of layers. It can have many, many hidden layers, which are not logical, they're not reasonable, they're mathematical. And then the machine spits out an answer. And let's say that we're looking at supervised, and it says this is a cat. And we say, no, 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 that's not a cat. And it's important for you to know that it's not a cat. And go back and figure out why you thought it was a cat and fix it. So the machine is going to work backwards and is going to find which node overrode the whole decision and which node caused that one to change its mind and which previous one caused it to change its mind. And this is called back propagation. Now, this is as much math as I'm going to show you. Back propagation says, oh, I see why I thought that was a cat. I'm going to change the model, the mathematical model, so if I see something that looks like that again, I'll know it's a skunk. Now here's where things get fun. Decision trees, random forests, support vector machines, neural networks, deep learning. What if we put them all together in an ensemble? What if we gave the machine the choice over which algorithms to use and had it use all of them to figure out which one's best? Yeah, it's a little meta, but this is where data scientists are playing these days. It gets really interesting really quickly. So that's what it is, and that's how it works. But what's it good at? Well, two things specifically: dimensionality and cardinality. And if you're like me, those terms mean nothing. So allow me very briefly to explain. Dimensionality is attributes per object. Okay, what's an object? It is a thing in your database. Let's call it a person. So you've got a bunch of people in your database. Big data, lots of people, great. But if you know a lot of things about them, that's many attributes. You know their name, address, phone number, when was the last time they called, what were the last 16 pages they looked at on your website, what's their phone number? Those are attributes about them. Cardinality is options per attribute. So let's take phone number. That little yellow dot is that individual's phone number. How different is it from everybody else's? Completely. The number of options of phone numbers is as many people as there are. Everybody has their own phone number. So what is their age? Well, somewhere between 1 and 120. What is their zip code? Well, there's 43,000 zip codes in the United States. What is their phone number? Well, there's 7 billion people. There are 7 billion phone numbers. So there are lots of dimensions. We know a lot of different things and lots of options per attribute. And you put those together and there are so many permutations, the human mind can't handle it, but the machine can. The machine is really good at high dimensionality and high cardinality. So here's a quick recap of what we covered so far. Supervised and unsupervised, reinforcement learning, decision trees. Yeah, I skipped over support vector machines, didn't have enough time. Neural networks, putting them all together in an ensemble, and then what is the machine good at? Okay, so how is it useful? Well, it's good for marketing. If we go all the way back to the definition of artificial intelligence, you remember it included things like robots. Well, yes, robots. So this is a Japanese hotel that uses a robot to check you in. Step up to the counter, the robot will check you in, unless you go to the next counter over, and then this robot will check you in. And if you're really good, this robot will bring you your midnight snack. Robots are also being tested in stores. So the Lowe's home improvement stores are using robots to greet people at the door and direct them to what they're looking for. When we get to computer vision, here's a company called GumGum that looks at social media to identify what's out there and reports back to you on where your image shows up, your brand shows up, who's talking about you, what kind of influence they have, whether you'd like to reach out and engage them with further promotions or to use their visuals, and of course to track the competition. Now, computer vision is also useful for augmented reality, here to find your store or to identify pricing, here to bring to 3D life a two-dimensional picture, or just to help you find recipes off the ketchup bottle. Warby Parker is using it to help you identify what kind of glasses would look best on you. When it comes to natural language, well, you talk to your phone, right? You talk to your Alexa or your Hey Google device. These things are becoming more ubiquitous and are going to be becoming a serious challenge to marketers. When you ask Amazon to send you more paper towels, which brand is it going to choose? And how do we as marketers get on that list? Now, when we bring these together, it becomes very compelling. Natural language processing, conversation bots, voice recognition. I'm not sure if you're familiar with the Staples Easy button, but take a look at this video.
It's just a blue pen, right? Sounds simple, but it's surprisingly complex. What brand? What type? What quantity? Now magnify that across the chaos of all the stuff you order for all the people in your office. What if managing this was as easy as saying,
"Hi, please tell me what you need."
Blue pens.
Now it is. That's the magic of the Staples Easy system.
Hi. please
Using
tell me
simple
what you need.
spoken words,
Any more Post-it notes?
the Easy button lets you order everything your team needs to be productive, fed, and caffeinated.
French vanilla coffee and letter-size copy paper.
Got it. That was easy.
It's an extra set of hands, helping you save countless hours, manage costs, and maintain control of ordering supplies.
3 boxes of Sharpies.
The Staples Easy button brings the power of on-demand to businesses on any device, exactly when something is needed.
Dry erase markers.
Order with voice through the Easy button or through the app. Order with a text, with an email, with a Slack bot, with a photo, or even with Facebook Messenger. It's easy to track shipments
I need to check on my order.
and get in touch with customer service. The brain behind the Easy system is IBM Watson. Watson's cognitive intelligence turns what you say into data, and then turns that data into answers you need. The Staples Easy button learns over time. With every interaction, it becomes more personalized and more intuitive.
Please tell me what you need.
So when you tell the Easy button you want blue pens, it knows the exact blue pens you want.
Got it. That was easy.
That's the Staples Easy system.
I think you'll agree that's a pretty compelling story and a glimmer of what kinds of opportunities we as marketing people have to work with in the future. But what about today? How do you bring this on board? How do you bring this into your company? What's the first thing you need to do? Step one, you are responsible as a marketing person to know marketing and to know the industry that you're marketing for, what questions you're trying to ask, what problems you're trying to solve, what business imperatives you're trying to address. The machine will only do what it's told. You need to know what to tell it. Number two, know your data. Where is it collected? How is it collected? How is it stored? How is it cleaned? How is it integrated with other data? How might it go wrong? How might you bring two data sets together that address different realms but somehow need to find a way to mesh together? That's a human problem. So where do you begin? You start with tasks that are repetitive and sort of boring and have a lot of data available, whether it's sorting sales leads or coming up with a response to social media questions or creating a chatbot. These are the things that there are lots of iterations and an opportunity for a machine learning system to help you. The next question is, should you build this stuff or buy it? And I am strongly on the buy side. Building it means you have to hire data scientists. You're going to compete with everybody and their brother who is out there building this stuff to find the PhDs who can figure out algorithms. But at the same time, large companies like Google and IBM and Salesforce.com are adding machine learning tools into their data systems. If you're a Google Analytics user or an Adobe Analytics user, those companies are building machine learning systems into their marketing platforms. But there's also a lot of venture capital money being spent at startups. So startups are coming up with ways of taking what data you have, applying their data science, and giving you insights and answers. You have to decide what problem you want the machine to solve, and then You have to decide what data it should consider. If you give it too little data, doesn't have enough to work with. If you give it too much, it won't be very confident in its answers. So there is a correct amount or a correct variety of data to be considered. And finally, become proficient at the smell test. Now, this is something that's uniquely human. The machine is going to take the question you ask, take the data that it's been given, and come up with an answer. And if you change the data, it can change its answer. That's fine. But it can't tell you whether the answer is meaningful. There are some things a human can look at and just go, nope, that is not going to work. I can tell. So where does the human come into this? What advantage do you have over the machine? The machine is crackerjack at large amounts of data. It can correlate quickly. It's very accurate. It's low cost. It doesn't get tired. It doesn't take vacations. But it ain't human. It doesn't understand compassion or empathy or insight. It doesn't understand ambiguity. It cannot take two conflicting concepts and make sense out of them. And that's what the human can do. So here's your homework assignment. Your job will be to stay tuned with what kinds of tools are available and what they can do. They're changing rapidly. Stay tuned. Number 2, train your bots. This is a very interesting area. You're already using spell check, right? Well, there's a system that Google has that will guess the rest of your sentence, not just the spelling mistakes, but suggest entire sentences for you to just hit return and make it faster for you to write up a response to an email. If those kinds of tools are available to everybody, then your special value comes in training your version of that tool to understand you better. Train your bots, because eventually you're going to walk into a company and you're going to have an interview and they're going to say, what experience do you have? What tools do you use? Well, I'm very good at Word and PowerPoint and Excel. And here are a half a dozen bots that I have trained to help me do market research, to help me do analysis, to help me write reports, to help me identify good graphics to use. And those are part of your skills. You're bringing that trained bot into the picture, and that makes you a better catch in the future. My name is Jim Stern. I run the Marketing Evolution Experience Conference. I'm co-founder of the Digital Analytics Association, and I hope you now have a strong introduction to artificial intelligence for marketing. Thanks for listening.